Hey guys, David here and welcome to another video. Why is my Prusa weird like this? Why is it at an angle? Oh, that's because I have the Quinly system from 3DQue installed on it, and what it is a way to automate your 3D printers. Before we get right into it, we have to take a couple steps back though. FDM 3D printers can be quite reliable, and oftentimes you'll be printing overnight and or printing many different parts. But if you're printing smaller parts, for example, then if you want to do a longer print to really utilize your printer to the fullest potential and print while sleeping or away at work, then you have to nest a bunch of parts onto the build plate, and if one of them fails, the chance that all of them fail is pretty large, and then you have a bad day. And if there are, even after that, you still have to go in manually, take off all the prints and then restart a new one. There are plenty of software where you can control your 3D printer through a web interface like with Octoprint, for example, and you can even do those that you could remote into that. But still, after the print job is done, it's on your platform and you kind of have to get rid of it somehow. Now 3DQue tries to solve this problem by giving you two separate parts. On one hand, they give you the hardware. They have their warp build plate, which is especially engineered that it holds onto all materials quite well when it's heated up, and then afterwards, once it's cooled down, it releases of them fully. It doesn't just kind of release some of the grip, but it releases enough that the print head can then just kind of bump the parts off of the build plate and then continue with a next job. This is also why the printer is angled. That's just so that the parts can fall off the build plate more easily. Then the second component to this is the software. Without good software, a feature like this is completely useless, as you want to be able to properly schedule all your prints and maybe even have multiple printers going at the same time. If you have something like a print farm, then this will be super convenient, as you can basically run jobs throughout the night and don't need to get up at 3 AM to switch over your build plates. These two components is why reviewing this product is not quite as straightforward as just looking at the price point and looking at what hardware you get and being like, that does not add up. And that we will get to the software, the second part of this video, but first I want to talk a bit about the hardware. Just for full disclosure, 3DQue did send over this unit for me to try out, and I have worked back and forth with them, giving them feedback as I've tested it over the past few months, and especially also with the software. But they have no influence on this review whatsoever, and I'm trying to just give you the full story of what I have experienced over the few months that I've had this tested here. There are many different ways you can automate 3D print job. You could either take off the entire build plate and then have a system that swaps off on a new build plate. That is one system, but that's relatively complicated, as you need to have a kinematic system that can take the build plate, lift it off, and put a new one on there. That means a bunch of motors, linear ways, which is expensive, complicated, and does not really allow you to use the printer in a normal way anymore. Then there is the way of taking the print off of the build plate. And that's what 3DQue is doing with their Quinly system, and they really made it super simple in a way where you don't have to modify a lot of your hardware. Installing the Quinly system only takes like half an hour, and in probably like 10 minutes you can completely disassemble it again and your printer is fully stock with no modifications. There's nothing permanent about this install whatsoever. The kit includes a bunch of 3D printed parts for the various connections and to relocate your LCD display up here, and also, this part is supposed to be here. This is to kind of guide your parts off of the build plate, as when your build plate is moved up here, there would be a chance of it getting caught. Now, I actually received my Quinly unit many months ago, but due to the software still being in very early stages, which I will go over later, I decided to delay this review quite a bit so that the software can mature a bit more. But now we're at that stage, and this is why I got a very early sample where they printed this part in a very bad orientation. It was printed standing up, so the layer lines were this way, and that combined with the tolerances being slightly off, the parts where it pushed in just kind of caused it to crack, and over time this part actually fully broke off. But they told me that they are now printing these parts laying flat, so this should not be an issue anymore. You also get two more aluminum extrusions for the base, and they look exactly the same as the stock Prusa ones, which is really nice. actually looks like this printer was supposed to be this way, and it's not just like a cheap add-on that makes your printer look completely ridiculous. Now they do also make them for other printers, like for example the Ender 3 and many more, also more coming in the future as well. Their goal is to have their system compatible with half their 3D printers on the market by the end of 2022. And the last part I've already hinted at it is their bed surface. Now you do have to supply your own steel sheet to apply this to, but if you like have your Prusa for a while, you might have one that's already scratched up, and you can just kind of slightly sand it to make sure that it's nice and flat, and then apply the sheet onto that. They're not saying exactly what material this is, they're just saying it's not a PEI sheet, it's not a glass sheet, it's none of the common materials. Now to me it looks somewhat similar to like an FR4, like a PCB material, but it has a special coating on top, and that coating also means that you have to be really careful with it. You are not allowed to use any sort of alcohol-based cleaning, and even with soap they're quite particular about only using mild dish soap to clean it. For the most part, I would say that's true. The surface has not degraded in any way from me using it. The only parts where it is scratched up is where well, it was my fault and I had the printhead digging into it. They are very particular in their manual. If you go through it step by step, they make sure that something like that does not happen. And on the first install, it also didn't happen to me. But later on, I changed some stuff around. I was not as careful anymore, and I thought I could just kind of do it quickly. And my nozzle was too close to the bed. Since the build surface is quite thick, it's not just a very thin film like a build tack, but it has some thickness to it, and it is non-metallic. So the bed leveling sensor still triggers off of the sheet underneath. And what that means is that the room for error is quite small, as you need to have the bed leveling sensor very close to the nozzle, but you'd still need it above, otherwise the leveling sensor is going to hit some stuff. But the trigger distance, at least on the Prusa Mark III, the probe on the Mark III's is slightly different, so it might be better there. But for me, the margin for error there is extremely slim. But if you get your C probe positioned exactly, then you can set up your C offset, save that, and that's a one-time calibration thing, and it works perfectly after that. Then the last thing you will need is you will need your own Raspberry Pi to install their software on. It just connects to the USB port of your controller board, meaning that you don't have to modify anything of the printer's firmware. It will stay completely stock. And then on the Raspberry Pi, you just install their software, which works exactly the same as installing Octoprint or any other print software on a Raspberry Pi. They have a detailed guide that makes it quite simple to go through it. And afterwards, you can log into the web interface and get started. The web interface is for the most part very simple to use, and it has just the controls that you need. I will go over it slightly more in depth later. I'll actually show you a screencast of it. But what I want to talk about now first is the calibration. Normally when you're printing, you just kind of put your heated bed to a temperature that sounds about right. For PLA, you just kind of put it to 60 degrees, which is enough to hold on to it. Depending on the brand, it might hold on slightly more or slightly less, but it doesn't really matter since I just take off the build plate afterwards, flex it to get the part off. However, with this system, you're relying on it sticking while it's hot and then perfectly releasing once it's cold. And what that means is that you need to perfectly dial in your temperatures. If your temperature is too low, then it will not stick properly to the bed and it will fall off prematurely. I have plenty of examples for that. But if your temperature is too high, then it will stick perfectly, print very well, but then once it's cooled down, it might not release fully, and your printer will try to knock it off the build plate but not have enough force and just kind of error out. So this means that you need to play with your heated bed temperature for every single material that you have. And I'm not just talking about PLA as a material, I'm talking about every single brand. Some of my PLA worked perfectly fine, while others I had to bump the temperature up quite a bit for it to stick properly, and if I were to go back to the other material and use the same temperature, it would not release afterwards. I found that the range is quite slim, especially if you're printing models that are have a tendency to warp because they're like rectangles or something. Then for PLA it's quite difficult to find the exact point. What helps a lot with that is to increase the extrusion width for the first layer. I used to print at maybe 0.4, 0.45, basically the same extrusion width for all the layers, but with the Quinly system it really helps to put the extrusion width of the first line to about 0.6 if using a 0.4mm nozzle, so 1.5 times the nozzle diameter. This just kind of pushes more material onto it and gives it more chance for a proper bond. You can also increase your nozzle temperature slightly if you're having trouble with it sticking. This way the material is a bit more liquid and has a bit more time to cool down nicely onto the build plate. With other materials, the story was almost the opposite. PETG also works great on this surface. On the PEI sheet, actually, I have to use some glue sticks because the PETG otherwise rips off the PEI sheet. But on here, it works just a charm. The PETG does not stick too much to it, but it sticks enough to hold on to it very well. Still, the range for it is quite slim, and you will have to adjust it for every single material, but PETG was no problem whatsoever. Also, ABS worked a charm. And there I actually had to put the temperature a bit lower than with my PEI sheet, otherwise I could barely get it off of the print bed. These are the three main materials that I have tested on my Prusa with this bed, but according to them, just about every material they have tried so far worked quite good on it, which is actually very impressive, as most just kind of standard build surfaces have trouble with certain materials, like PEI sheet, which is great for almost everything. With something like PETG, it will stick too much, but with this one, it just works. Alright, so here we are inside of the Quinly web interface. Now I do quickly want to mention that this is still in beta. They have a release version that's the previous one, which is quite limited in features, and they have completely overhauled everything and made a lot of improvements, but that is still in beta. This is not even the quite newest beta version, but the official release for this will be out very soon, and it will look mostly like that, just like some of the little bugs that you might see here and there will of course be fixed. So here in the main interface you can see your printer. Right now it says suspended. That just means that it is not actively printing and will not take any new print jobs by itself. If I click here on unsuspend, it will go out of this mode and see if there are any jobs available, and then take those and start printing. When it is printing, you can also see a progress bar here. Down here you have some statistics of your printer. You can see the current hot end and the current bed temperature, also how long your printer has been online for. And if you have a webcam connected, then this will show up in this window here. On the right here, you can just see a quick overview of what is next in queue and what has completed already. Right now I just have this one item here in the queue, but let's go over to the Files tab here, and that is where you can upload files. You just click on that, you can select as many files as you want and upload all of those G-code files, and then you can see them here. On the side here, you can also create various folders to kind of organize all of your files on here. And on here, then you can select a file that you want to print, for example, or you can select two files that you want to print, and then you can add them to your queue. When you click on here, you get a little dialog box where you can, of course, set the quantity of how many you want to print, and you can also set the release temp. And this is actually a very important setting, and will greatly influence of how well it will release from your build platform, and how long it will take. Now you may or may not remember from your physics class that the temperature of a hot object in a room does not decrease linearly. So going from 60 degrees Celsius to 50 degrees Celsius on your bed is quite fast. After you turn off your heater, it'll take a minute or two and it'll have dropped these 10 degrees. But let's say your room is 20 degrees Celsius, and then going from 35 to 25, that will take a lot longer, as it is getting very close to the room temperature and therefore decreases in temperature a lot slower. Now, if you are in a fairly cold room, let's say 20 degrees Celsius or below, this is not an issue at all. The default release temperature is 29 degrees Celsius, and at this temperature, basically all materials will release no problem. But when I first started testing this product, it was still summer, and my room was around 27 degrees. And going down to 29 degrees when the ambient temperature is 27 degrees takes forever. It would take about an hour in between print jobs until the build plate had cooled down fully and was ready to eject the parts. Now you can increase this release temp slightly, and depending on what material you're printing, you can get away with that. But you definitely need to test this thoroughly, because even just going to 35 degrees for the release temp, which would have cut the time in half, already was too much, and it did not release quite anymore. And if I decreased the build plate temperature from 65 to like 55 degrees, then it would release at 35, but it would also release while printing and fall off, which is not a good day. For PLA, I usually leave it at like 29 or maybe 30 to 32. But if it's printing something like ABS, where your build plate is like 100 degrees or more while printing, the release temperature might also be sooner. But that is something you will have to experiment with for every different material. One way to get your platform to cool down more quickly would also be to add a fan. And they have actually showed off a really cool system where if the build platform is at the very back, which is where it parks for cooling down, then you can have a little switch there that activates a fan that blows over the build plate. This is a very easy mod that does not require you to modify any firmware or anything, and would be quite convenient. But that is something that you will have to add yourself. This will actually just about cut in half the time it takes for your build plate to cool down. But if it's during the winter times and your room is around 20 degrees or 22 maybe, then for me it didn't take more than like 10 minutes for it to cool down and then start the switchover sequence. So let's send this to the queue. And then we can click on View Queue, which will get us to the Queue tab here. And here we can see everything that is coming up and which quantities and at which release temperature. If we, let's say, don't want this anymore here, we can of course also delete it from the queue. And that is already pretty much it. You can see it is fairly basic. You can of course also send commands directly to your printer, and that is right now also the only way that you can for example, change your flow rate or your extrusion speed or move your printer in any way. Now this might seem quite limiting, but if you really think about it, your LCD on your printer is still very much usable. And if you want to do something like, I don't know, move your printer up, then you are probably already at the printer, so it's just as convenient to do it through the LCD screen. You also have to consider that this software doesn't just work with one printer, but also with print forms. And there it is quite a bit more complicated. Like if you want to increase your extrusion multiplier, then what is that supposed to apply to a specific printer or to just to a single print job? So they are working on this, and this will come in the future, but it is not as simple as you might think. So now that you know the entire system and know what's included, what it can do, I feel like there is one big thing in the room that we have to talk about, and that's the price for this kit. Now it varies on which configuration exactly you go with and which machine it is for, but it is not cheap. Now to give you some background, this is not something that gets shipped out of China in mass volume at super poor quality. Instead, they are a Canadian company and are printing all the parts in-house and shipping it out themselves. My parts actually came packaged with like 3D printed packaging divider, which I thought was really cool, really nerdy. But this just means that it is not super mass market cheap. Also, a big part that you are paying for is the software. And in its current state, while it is a lot more usable than the first generation was, it is still fairly bare bones. You could also just set up a very similar system by getting some extrusions, printing some your own angled brackets using a PEI sheet, and writing some custom macros inside of Octoprint with the continuous print plugin, and get a very similar system for a fraction of the price. Now this will require a lot of tuning on your part, and it's definitely more of a DIY solution, while this is a somewhat finished solution. But for the home tinkerer, it might be a consideration. Now I've not tested how well you can get stuff to release from PI sheets, but while this print bed does its job quite well, it is not magic. So it should be possible to get something similar as well on a DIY approach. But now let's turn the table and let's talk about who this is for. If you have a Prusa, when I think this makes the price point for it makes a lot more sense, you already spent almost $1,000 on your printer. So a few $100s for an automation add-on is not that much more expensive. And if you have the demand to print a lot and maybe you go off to work over the day, but you want to continue printing and then as well overnight, then, well, something like this would be great. You can just add all the stuff to the queue, let it print, check by it once or twice a day, replace the filament spool or whatever, make sure that it's still running. This way you can get a lot more productivity out of your 3D printer and maybe print the same amount that you would need 2 printers for otherwise with just 1 printer, and at that point this is a lot cheaper. However, this also means that you probably don't want to have this printer in your bedroom. You want to have it in your garage or your basement. And if that garage gets too warm in the summer, then you will have a bad day as well. On the contrary, if you have a very cold basement, this might actually be ideal because the prints will cool down faster and release more easily. But of course, this is not just for a single printer kind of private usage. Also, if you are planning on running a small print farm, a system like this could make tons of sense. You can automate it and basically maintain as many printers by yourself as you might need 1 or 2 employees otherwise. So the cost of this system will then very quickly come back in saved labor costs. It is also very beneficial if you kind of print in the same material all the time, because, well, of course, unless you have a multi-material upgrade, you can only continuously print with the same material. Also, if you switch a bunch of materials all the time, you will have to recalibrate your system all the time, which is not as fun. But if you kind of print very similar parts a bunch, then this is also a lot more useful. Now, for me personally, I don't really have a need for this anymore on my Prusa, since my Prusa is in the bedroom, so I can only print during the day, and I'm home most of the time for at least half the day anyhow, so I can easily switch over the print jobs myself, which is quicker and more reliable. So it is not really necessarily for me, but if I ever have this printer somewhere else or have more printers that I want to print with, then I will definitely revisit this system. So with that said, leave some comments down below. What do you think? Do you like this system? Have you ever tried something like that? Or do you have any ideas of how you would want to do it differently? Leave a comment down below. I'm happy to read them. Also, if you like this content and you want to see more of it, make sure you're subscribed so you don't miss any future videos. With that said, thanks for watching and until next time.